Good day, viewers. Here is an Olympiad algebra. How to solve this problem for the value of x. We have x to the power 3 plus 1 equals 1 minus 3x divided 1 plus x. And we have to cross multiply first. By doing so, we have, if this multiply this, we have this as 1 plus x multiplying x raised to power 3 plus 1 equals 1 minus 3x. And with this, which is x cubed plus 1, suppose I have it as x to the power 3 plus 1 to the power of 3, which gives x plus 1 bracket x squared minus x plus 1 all bracket. We are going to replace it, and here we have 1 plus x bracket open bracket. For this we have x plus 1 bracket x squared minus x plus 1 equals 1 minus 3x. So here 1 plus x and x plus 1, they are commutative, either of the two. So which means when we combine this 1 together, we are going to have it as either 1 plus x or x plus 1. So we have 1 plus x to the power of 2 bracket. If I place this and this together, we have this as x squared plus 1, this in bracket, minus x, all in bracket, equals 1 minus 3x. So here again, if you have x squared plus 1, it's just like x squared plus 1 square. And x squared plus 1 square equals x plus 1 square minus 2x. So by replacing it in this as well, we have it as 1 plus x to the power of 2. So we have this larger bracket, and we put all this, which is x plus 1 square minus 2x minus x, all in bracket, equals 1 minus 3x. So here, since I'm having x plus 1 here, I'm going to change this one to x plus 1. We have x plus 1 to the power of 2. So bracket, here is also x plus 1 to the power of 2. This 2 is minus 3x, all in bracket, equals 1 minus 3x. By opening the parentheses in this, we have x plus 1 square multiplying this. We are going to have it as x plus 1 square, but both of them are the same, so which means I can let this one takes another square minus. So when this multiply this, we have it as minus 3x bracket x plus 1 square. And for this one, when I take the whole of this here, we have it as minus bracket 1 minus 3x, all in bracket, everything equals 0. And looking at this, it forms a quadratic equation. Here is x plus 1 square, just like the variable x, and here is x plus 1 square, the second variable which attached to b, and here is the constant term. So which means we are going to apply the quadratic equation here, where we have a, which is the coset of this one, equals 1, and we are going to have b, which is minus 3x, and here we have c, which is minus open bracket 1 minus 3x. So instead of x that we always have here, we are going to change it to x plus 1 square equals, and we have minus b, which is minus 3x. So we have it as 3x plus or minus the square root of So we still have this as minus 3x squared minus 4, and a here is 1. So 1 is still going to go, as 4 times 1 is still 4. And while for this we have it as minus open bracket 1 minus 3x, all in bracket, everything divided by 2. So the next thing is we have x plus 1 raised to the power of 2 equals, here is 3x plus 1, the square root of, for this one the negative will go here when we open the parentheses, and what you have here next is just 3x to the power of 2. And here we have, if minus multiply minus, we have plus, and 4 multiplied by 1, that is minus, that is going to be plus 4, and here have 4 multiplied by minus 3x, that is minus 12x. So everything divided by 2. Again, we have x plus 1 square equals, here is 3x plus or minus the square root of, so the whole of this thing, when we factorize it, what we are going to have here is 3x minus 2 raised to the power of 2. That's what we are going to have when we factorize this. When we expand this, we get this, and everything divided by 2. Therefore, this and this cancelled each other. When they cancelled, we are left with x plus 1 square equals, here we have 3x plus or minus 3x minus 2, all divided by 2. And we have plus or minus here, so which means this one is either equals to plus or equals to the minus of this. So for the positive side, we have x plus 1 square equals, so we add this together with positive, what we get is 6x minus 2 divided by 2. And when we go for the negative part of this, we have x plus 1 square equals, what we have only is 2 divided by 2. Alright, so to deal with this, we have the expansion of this, which is x squared plus 2x plus 1 equals, so when we take out 2 here, what we are going to left with is 3x minus 1. And taking the whole of this one here, we have x squared plus 2x plus 1 minus 3x plus 1 equals 0. And here is x squared, so this and this is minus x plus 2 equals 0, so which is a quadratic equation as well. So by solving this, x squared minus x plus 2, when we plug it in the quadratic formula, so what we are going to have here is x is just 1 plus or minus, so the square root of minus 3. Alright, so 4 multiplied by 2 is 8, and we have 1 here, so we are going to have minus 7 divided by 2. And minus 7 here is a complex root, which we have the solution as x equals 1 plus or minus I root 7 divided by 2. That's what we have for the first solution to this. And while for the second solution, so we have this as x plus 1 square equals this. So when we expand this, we are going to have x squared plus 2x plus 1, and here is 1, we take it to this side, we have it as minus 1 equals 0. So we have this cancelled, and here is x squared plus 2x equals 0, and by taking out x, we are left with x plus 2 equals 0, which means that x equals 0 or this equals 0. So x equals 0, which is the real root, and x plus 2 equals 0, that is, we have x equals minus 2. So we have two real roots, and we also have two complex roots. So this is how to solve this problem. And thanks for watching. And please don't forget to subscribe to this channel for more exciting math contents like this. I will see you in the next video. Never stop learning. Bye bye.